In this video, the learner will analyze and write two-column proofs concerning angle and segment relationships. First, we're going to go through a proof together. We're going to prove that if AB and CD are congruent, then AC and BD are congruent. So we always start off with our given statement here. So we have AB is congruent to CD because it's given. We know because the segments are congruent that the measures are equal, so that's because of the definition of congruent segments. We know that this segment BC is equal to itself by the reflexive property of equality. And because both of those segments contain segment BC, we can consider the segment addition for both of those segments. So we have AB plus BC equals AC by segment addition, and CD plus BC equals AC by substitution. Because we knew CD was equal to AB, we substituted CD in. Next, we have CD plus BC equals B to D because of the segment addition postulate. And so AC equals BD by the transitive property. Because the measures of those segments are now equal, we know they're congruent by the definition of congruent segments. In this next proof, we're given that the measure of AC is equal to AB, and AB is equal to BX. We're also given that CY is equal to XD, so we're given these two segments that are equal to each other, and then AC is equal to AB, and AB is equal to BX. What I've done here is given you all of the statements, and I want you to fill in the reasons as they logically fall into this proof. I also want you to answer this question. State the conclusion that can be drawn from the statements given using the property indicated. So if we have the statement LM congruent to NO and NO congruent to PQ, by the transitive property of congruence, which one of these conclusions could we make? Next, we're going to look at this proof where we have some missing statements and some reasons. I want you to fill in these blanks on your own. Next, we have a couple theorems that I want to take a look at. The first one is the congruent supplements theorem. Recall that supplementary angles are angles that add to 180 degrees. The congruent supplements theorem says that if two angles are supplementary to the same angle, then those angles are congruent. So for example here, if angle 1 and angle 2 are supplementary, and angle 2 and 3 are supplementary, this theorem tells me that 1 and 3 are congruent because they're both supplementary to that same angle 2. So if angle 1 is 130, and it's supplementary to angle 2, that means this angle is 50 degrees. But if angle 2 is supplementary to angle 3, that means they have to add to 180 degrees. Therefore, this one is 130. Notice now 1 and 3 have equal measures. That makes angle 1 and angle 3 congruent. Along the same reasoning, we have the congruent complements theorem. Remember that complementary angles are angles that add to 90 degrees. So this theorem states that angles complementary to the same angle are congruent. So if I have angle 4 and 5 that are complementary and 5 and 6 that are complementary, because both 4 and 6 are complementary to that same angle number 5, angle 4 and 6 have to be congruent. So if angle 4 is 25 degrees, and it's complementary to 5, 90 minus 25 would be 65. But if 5 is complementary to 6, I would subtract 65 from 90 and I get 25. Notice that angle 4 and angle 6 have equal measure, and because they have equal measure, they are therefore congruent. Now we're going to look at a proof that actually uses the congruent supplements theorem. We know 1 and 2 are supplementary and 2 and 3 are supplementary. We're going to prove that 1 and 3 are congruent. So we have our statements column and our reasons column. We always start out with our given information. So we are given that 1 and 2 are supplementary and 2 and 3 are supplementary. If we know we have supplementary angles, that means those angles are going to add to 180 degrees. Because we haven't stated that yet, that is our next statement. So measure of angle 1 plus the measure of angle 2 equals 180 comes from that first statement. Measure of angle 2 plus the measure of angle 3 equals 180 comes from that second statement. And we knew that we could make these statements because of the definition of supplementary angles. Next, because we know both of those equations equal 180, we can substitute and say the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 2 plus the measure of angle 3. Notice we have the measure of angle 2 on both sides of that. We can actually subtract that angle out from both sides because the measure of angle 1 is equal to the measure of angle 2. And we're left with the measure of angle 1 is equal to the measure of angle 3 by that subtraction. Because now the measure of angle 1 is equal to the measure of angle 3, we know those angles are therefore congruent because of the definition of congruence. Here I have some given information that angle 1 and angle 4 form a linear pair, and the measure of angle 3 plus the measure of angle 1 equals 180. So we're using this diagram here to prove that angle 3 and angle 4 are congruent. You're given angle 1 and angle 4 are a linear pair, and angle 3 and angle 1 add to 180. I've given you the statements for this proof, and I want you to fill in the reasons. In this proof dealing with angles, we have that ray DB bisects angle ADC. We want to prove that angle 2 is congruent to angle 3. I've given you the reasons in this proof, and I want you to provide the statements that show angle 2 is congruent to angle 3 using these definitions and properties.